Hey guys, Miss Miklos here, and this is going to be our Chapter 6 review. And I'm just going to go through a few problems on each concept that are straight off of our review worksheet. So the first concept I want to talk about are exponents, and so I'm going to go through number 2 on our review worksheet because I think this is a good one to demonstrate our two major exponent rules. So looking at this problem, the very first thing I'm going to do is simplify whatever's inside my parenthesis. So I have x to the fourth, and my product of powers property tells me I need to add these two together. So I get x to the negative second power squared. Next thing I need to follow in our order of operations is exponents. So I'm going to have to take x to the negative second power to the second power. This is our power of a power property, which means I multiply those two together. So I have x to the fourth times x to the negative fourth. I'm going to add these together, and I get x to the 0 power, and we know anything to the 0 power is equal to 1. So this is a really good problem for us to go through because of the fact that I had to deal with our product of powers property where I added. I also had my power of power property where I multiplied, and I also had to deal with a power of 0, which we know is always equal to 1. Number 4 is the next one we're going through, and looking inside the parentheses here, there's actually not much I can do. So I'm going to start by dealing with this exponent. So I'm going to think of this as 3 to the 5th power, x to the 10th power, y to the 5th power, over 9x to the 10th, y to the 6th. So now I'm going to look at these one at a time. I know 3 to the 5th power is really 243, so I'm just going to go ahead and write everything else out. And now we're going to go ahead and look at my coefficients and simplify those. I know 243 divided by 9 is actually 27. Oh, and I just realized that I copied this wrong. This should be y to the 6th power. Okay, now when I compare these x values, this is when we battle, and I know 10 minus 10 is 0. Anything to the 0 power is 1, so our x's are canceled out. Looking at my y values, when I battle those, my denominator has the higher exponent, and it's 1 higher, so I just have y in our denominator. So my final answer here is 27 divided by y. Notice that I didn't really deal with my negative exponents here, but if I did want to move any negative exponents, I would need to go ahead and move them to the other side of the fraction in order to make them positive. So this is just a good recap on dealing with fractions. Definitely study quiz number 1, specifically problems 1 through 4. Those are similar to what we'll see on our test. Next major concept is evaluating, and we actually learn 2 ways to evaluate. Direct, which means I'm taking this value of 3 and substituting it into every x. And we also use synthetic substitution, which is actually what I'm going to go ahead and practice using. On the test, you guys can use whatever the heck you want. Now, I just took this line of coefficients and wrote it out, and I know whatever I'm substituting in for x is what I'm going to put in the box. I'm bringing down my 1. 1 times 3 is 3. When I add, I get 6. 6 times 3 is 18. When I add, I get 6. 6 times 3 is 18. When I add, I get 25, and this is actually our output, so our answer is 25. If you guys chose to use direct substitution, that's fine. We would also get an answer of 25. Next major concept is polynomial operations, and I'm going to start where we just have 2 polynomials, and we're subtracting them. This is number 9. So I know the very first thing that I need to do is to distribute a negative to every single term in that second polynomial, and that's what I wrote right here. So now I'm going to write things in descending order, and combine my like terms. So I have x to the fourth, and that is my only x to the fourth term. I have 5x cubed plus 12x cubed, which becomes 17x cubed. Negative 7x squared minus 4x squared becomes negative 11x squared plus 6. So whenever we're adding or subtracting polynomials, all I'm really doing is combining my like terms. The other major polynomial operation that we dealt with was multiplication. So I chose number 13 where I have 3 binomials. And what I'm going to do is I'm just going to choose 2 of them to start out with. And I'm going to go ahead and FOIL this so I get 2x squared plus x minus 12x minus 6, which is actually 2x squared minus 11x minus 6 times 5x minus 3. So I'm just choosing 2 polynomials, 2 of these binomials to start with, and I'm multiplying them together. Now I have a trinomial times a binomial. So I'm going to have to distribute, and I get 10x cubed minus 6x squared minus 55x squared plus 33x minus 30x plus 18. So when I combine my like terms, I have 10x cubed minus 61x squared plus 3x plus 18. So a lot of these multiplication problems can take a little time, but it's just important I take my time as I go through them because our actual math itself is not that bad. Now we're moving on to factoring. So I'm going to start with 18 because this is a good reminder that the first thing I always need to look for is a GCF. And in fact, I think we can take out 2u squared in both of these terms. So I'm left with 8u cubed minus 125. Now looking inside my parentheses, this looks to me like our difference of cubes pattern. So I need to figure out what is a and what is b. Well, the cube root of 8u cubed is 2u, and the cube root of 125 is 5. So if I'm following my pattern, it goes a squared, a times b squared. And our operations go same, opposite, always positive. I know that I cannot do anything more with this, so this would be our final answer. This is factored as much as possible. I know I'm factoring here and not solving because I do not have an equation, I just have an expression. Number 19 is another factoring problem, and this time I have 4 terms, so the first thing I should think of is to factor by grouping. So I'm grouping my first 2 terms together and then my second 2 terms together. In this first group, I notice that I can take an x squared out of both of those and I'm left with x minus 2. In my second group, I can take out a negative 9 and I'm left with x minus 2. So now if I look at these 2 terms, I have an x minus 2 in both of them, so I have x minus 2, and I'm left with x squared minus 9. Now I need to look again and see if I can factor either of these any further. Since this is linear, I know that's all I can do. However, x squared minus 9 is quadratic, so that's going to become x plus 3 times x minus 3. So this is factored as much as possible. One more factoring one that I'm just throwing in there. This is similar to what we had on our quiz, the second quiz of the chapter. And the first thing I look for always is a GCF. And when I take the 3 out, I am left with x to the 4th plus 5x squared plus minus 24. So now I need to go through and think what factors of negative 24 are going to add up to be 5. So I'm going to use opposite of FOIL, and I know I'm going to have x squared and x squared. And I'm thinking that negative 8 and positive 3, if I check my inside and outside, those don't work. But what would work is if I have a positive 8 and a negative 3. And now I need to look at both of these quadratic equations, or I should say quadratic expressions. They're not equations, we don't have equals. And I need to see if I can factor either of these further. And neither of these fits our difference of squares pattern. So I know this would be my final answer. So remember, whenever I have x to the fourth, x squared constant, we can actually factor it just like we factor a quadratic equation. Next thing we learned was polynomial division. And I'm actually going to start just by recapping how we do long division. First thing I need to look for is if I am missing any terms, I need to fill them in with zeros. I also need to make sure that this goes in descending order. Then I'm going to think to myself, what times x is x cubed? And in this case, it would be x squared. When I distribute, I get x cubed minus x squared. When we subtract, we change all of our signs. And I have negative 2x squared plus x. So now, what times x is negative 2x squared? So I'm going to go ahead and get negative 2x. When I distribute, I get negative 2x squared plus 2x. And since I'm subtracting, I'm going to change all my signs. And I get negative x minus 8. So I know that x times negative 1 is going to make negative x. When I distribute, I get negative x plus 1. I know I need to change both of my signs. So when I combine these, I end up getting negative 9. So my answer is x squared minus 2x minus 1, remainder negative 9. Or I could write this x squared minus 2x minus 1 minus 9 over x minus 1. Either of these answers would be totally fine. Now, just in case you are curious, this is actually a problem I could have used synthetic division for, and the reason why I know that is because my divisor is linear, which means my exponent is 1, and my leading coefficient is also 1. So this is a problem I could have used either way on. Now let's do one using synthetic division. So synthetic division, I'm going to start by putting the opposite of this number in our box, and I'm going to list out my coefficients, which are 1, negative 6, 0, negative 40, and 33. Since I was missing an x squared, I had to put a 0 into my line of coefficients. Now I'm starting by bringing down the 1. 1 times 7 is 7. When I add, I get 1. 1 times 7 is 7. When I add, I get 7. 7 times 7 is 49. When I add, I get 9. 9 times 7 is 63. When I add, I end up getting 96. So we know that this starts 1 degree lower than our original polynomial. So this is going to be x cubed plus x squared plus 7x plus 9. My remainder is 96. Okay, if we'd used long division on this problem, I would end up getting the same exact answer. Final concept is when we're finding all the zeros. This first one here, it's already set equal to 0. And I would go ahead and I notice that this is something that is factorable. In fact, my a value is x and my b value is 3. So if I'm following my pattern, it goes ab, a squared, a times b, b squared, and I know our signs go same, opposite, always positive. So now I'm going to set both of these factors equal to 0. So I get x equals 3, so that is one of my answers. For this other portion, I'm actually going to use quadratic formula. So x equals negative 3 plus or minus the square root of 3 squared minus 4 times 1 times 9 divided by 2 times 1. So I get negative 3 plus or minus the square root of 9 minus 36 over 2, which is going to be negative 27 over 2. So I end up getting negative 3 over 2 plus or minus 3i radical 3 over 2. Because we know whenever we have that negative inside my radical, that just means that I'm going to have an I. If I did a factor tree of 27, I would get 3 radical 3 because I have a pair of 3's I can take out. And I know that I need to divide everything in the numerator by the denominator. So if we look, we have 1, 2, 3 zeros, and this degree told me that we should have 3 zeros, so we know we're done. Lastly, I want to go through number 31. And looking at this, there's no way that we can factor this. So I'm going to start by thinking about our possible rational zeros. And I know that those are the factors of my constant, so plus or minus 1, plus or minus 5, and the factors of my leading coefficient, which in this case is 2, so that would be plus or minus 1, plus or minus 2. So when I divide those out, I get plus or minus 1, plus or minus 5, plus or minus 1 half, plus or minus 5 halves. So altogether, we have 8 possible rational zeros. On the test, there will definitely be some questions pertaining to possible rational zeros, so we need to know how to find them. Okay, now I'm going to go ahead and write out my line of coefficients. We know something is going to work if I end up getting 0 as my remainder. So I'm going to start by trying 1. So if I bring 2 down, 2 times 1 is 2, I get 5. 5 times 1 is 5, I get 2. 2 times 1 is 2, I get 5. 5 times 1 is 5, and I get 0. So I am happy because I know x equals 1 is going to be one of my zeros. Now at this point, there are 2 other things that we could possibly do. We could go ahead and keep using synthetic division because I know since this was x to the 4th, this is x cubed, so I would need to use it one more time until I get it to be quadratic. The other thing I could do, I notice a pattern here of 2, 5, 2, 5. That means that I could use factoring by grouping if I wanted to write this as a polynomial and solve from there. Once again, it really doesn't matter either way. It's just important we're aware that we have options. So I know this is going to seem strange, but I actually think that negative 5 halves is going to work, so I'm going to try that. So I'm bringing down my 2. 2 times negative 5 halves is negative 5, and I get 0. 0 times negative 5 halves is 0. When I add, I get 2. 2 times negative 5 halves is negative 5, so I get 0 again. So x is also equal to negative 5 halves. At this point, I need to take this, and I'm going to write that as 2x squared plus 2 equals 0. I notice we have a GCF of 2 there, so I'm just going to make it x squared plus 1 equals 0. So I'm going to subtract 1 from both sides, and then I know that I need to square root and do plus or minus. So I get x equals plus or minus I. So my answers here are going to be x equals plus or minus I, x equals 1, and x equals negative 5 halves. Now, it makes sense. I have 1, 2, 3, 4 answers. And if we look back at our original function, it was x to the 4th. Now, just a reminder that we can also use our graphing calculator as a guide to help us narrow down which numbers we should try for zeros. However, my stress to you guys is that if all you wrote down was this and I didn't see any of that other work, you would not get any points. Okay, I need to see your work and how you got those actual values. So keep studying and do your best.